Hello, I'm Liesel Ehlers and I'm presenting a lesson on Mathematics Level 4. It's in NCV. In our previous lesson we have discussed integration. We actually looked at the one basic rule, that rule that says how do you integrate if you've got an x to the power n. Okay, and we have done that. So now we will continue and look at more integration rules, the others that you must be able to do. If we do the next example by what we know already, let's try. Then I'll say I have to integrate, in this case, 5 over x dx, but I see the x is in the denominator and it shouldn't be, because if it's in the denominator I can't use this rule. It must be an x to the power n in the numerator. So if I rewrite this, I want to integrate 5x to the power negative 1, because I had a positive exponent 1 in the denominator, dx. Then I can write down the constant 5. I write down what I have, because that's what my rule said, plus a 1. And then I have to divide by this new exponent. Now, do you see what's going to happen? In my new exponent is going to be 0, and I may not divide by 0. So I have a problem. I have a problem because definitely something is wrong. At this stage, actually, you might feel like this. You might feel, I want to scream. Something is wrong. I can't use my rule because I definitely may not divide with a 0. But luckily, the solution is within the other integration rules that is given on my formula sheet, and you must be able to use them. So let's redo this problem, but now in this round I will use this rule that is given to me, so that the integral of k over x, do you see specifically if it's x to the power 1, then I cannot use this rule that I previously used for x to the power n, because I am going to end up having a 0 in the denominator. I'm going to divide by 0, which I cannot do. So the solution is, if I have a k over x, and I'll have to remember that, then the integral of k over x dx is k ln x plus a constant. Now let's use that. So I just have to remember and recognize this one as being k over x. So the integral will be 5, which is in the place of the k of the rule, ln x plus the constant. So I can just use the rule as it's been given to me on my formula sheet. Let's try next one. One of the other rules that you must be able to do and use is how to integrate e to the power kx and e to the power x. The integral of e to the power kx we see is e to the power kx divided by k plus the constant, and e to the power kx, e to the power x integrated just gives me the same thing, e to the power x again. So let's try and integrate what is given here. I have to integrate e to the power 3x. So I will be using this rule, and now I've got e to the power 3x, so the k is replaced by 3. So the answer will be e to the power kx, which is 3x in this case again, divide by the k, which is 3, plus the constant. If we go to a next example, this one I have more than one term. I've got 2 terms here. I see I am using again these rules where I have to integrate e to the power x or e to the power kx. Let's do them. So the integral, I will write down the constant. I have a rule that says e to the power x integrated is just e to the power x. Then minus, I will write down the constant, and then with e to the power 2x I can use this rule again that says it will be e to the power 2x, the kx, divide by the k, which is 2 in this case, and remember to say plus a constant. Is it simplified? I can simplify it a bit. It's 3 over 2 e to the power x. This 2 cancels, divides into the 4 2 times, which will give me minus 2 e to the power 2x plus a constant. I'm moving on to another example. Oh, before we do this example, I want to introduce another set of rules that you also must be able to use. Now, on your formula sheet, they might give you the rules of how to integrate sine x or kx, cos kx, and sec squared kx. But it might be that they don't give it with kx, but that they give it with x only. So let's look at both situations. If they have given me how to integrate sine kx and cos kx and sec squared kx, then I can actually just use this very easily. But it could be that they might give me only the integral of sine x, cos x, and sec squared x, not kx. And then I'll have to adjust it to know how to use it, even if kx has been asked. So let's look at an example. How will I adjust? Firstly, I'll say if this rules were given just with x and not kx, and I want to integrate sine kx dx, I will say, well, since I know what the integral of sine is, it's negative cos. I know it will be negative cos kx, because if you start with a kx, you will end up having a kx. But then, and I will actually use that rule of the integral of e to the power kx to guide me, because there I saw I had to divide by a k. So even in this cases, every time I have to remember to divide by k. So it will be divide by k plus the cos. So I used the part that said sine becomes a negative cos if it's integrated. But I remember to say kx will stay kx, and I remember to divide by k. The other thing you should know, and it's more important later, is that in these integration rules, these angles of x, these angles are given in radians, in terms of radians. These rules, as it is here, is true if the angle is measured in radians. But for now, we just have to apply the rules. So let's try and integrate the next question. In this next question, I have 1, 2, 3 terms to integrate. Let's do each of them. Okay, I'm going to integrate the first one, and we already in the first lesson on integration, we said that if I have more than one term, I can integrate each term and just join them with the plus or the minus, whatever I had. So if I integrate the first one, I'll say I have 5 over 3. The integral of e to the power x is just e to the power x. I have seen that on the formula sheet. The next one, I have to be very careful here. This is not a ln x. I have 3 ln 2. And I want you to actually take your calculator. If you take your calculator and you go to the right hand side, on my calculator it's on the right hand side, and you say actually what is 3? Press the ln button, 2, 3 ln 2, gives me a number. It gives me the value 2,07944, and there's more places after the comma. So actually I've got a constant here. So it's actually 3 ln 2, and I have a x to the power 0 next to it. So I can use that rule that I have, the basic rule I used in the previous lesson. I have a 0 as an exponent, plus 1 divide by 1. Plus, and now I'm going to use this new set of rules that we have just discussed. I have this constant a half. Then I have to integrate sine 4x. Now, if it happens that your formula sheet only gives you how to integrate sine x, you'll have to say, in other words, the integral of sine is negative cos. But if you started with a 4x, you'll end up with a 4x, and then you still have to remember to divide by 4. So I am ready now to just simplify it. Remember, I already integrated. So I shouldn't integrate again, I just have to simplify this, which will be 5 over 3 e to the power x plus 3 ln 2 times the x minus, and then if I multiply here, cos 4x is in the numerator, and I've got 2 times 4, which is 8. And I almost forgot to say plus a constant, which will be the 4 terms in this answer. In the next example, let's see if I can do this one. If I have to integrate 3x, I can use that rule that says an x to the power n integrated will give me x to the power n plus 1 divided by n plus 1 plus the constant as an answer. So I will write down what I had, exponent 1 plus another 1 divided by that new exponent 2. Plus, in this case, I remember the integral. I'm going to go back quickly. The integral of sine is negative cos. So it's going to be negative cos 3x, but I have to remember to divide by 3. Then plus, and now you have to be careful. I am not going to use this basic rule. The moment I'm going to take this x to the numerator position and change it to x to the power negative 1, it's then when you are going to end up wanting to scream, because you are going to divide with a 0, which is impossible. So you should actually remember this other rule, this one, that is on my formula sheet, where it says, how do you integrate k over x? So I'm going to use that one. It says it's 3 ln x. Plus, and then I've got a constant 3, which has got x to the power 0 actually next to it. So it's going to be 3x to the power 0 plus 1 divided by 1 plus my constant. Is there something to simplify? I can't simplify further, so there's my answer for this one. Let's move to a next example. In my next example, I can use the basic rule, but I'm not ready just to apply the rule because I do not have an x to the power n to integrate. What I have here is not in insert form, is insert form. It's not in exponent form yet, so I still have to change it to exponent form. Let's do that. If I change it to exponent form, it will be x to the power 2/3, because you remember that the exponent that is in the inside always gets the top position of the fraction, and the 3, which is outside, the cube, root cube, will go below the line. So I have plus this 3 sec squared 3x to be integrated. I can use my basic rule that says if you have 4x to the power 2/3, you actually have to add a 1 to that exponent, and then I'll have to divide. What is 2/3 plus 1? It will be plus 3/3, so it's going to be 5/3. Plus, now if I go back to this set of rules here, the integral of sec squared is sec squared x is tan x. So if I want to apply it, I will write down the constant. I remember the integral of sec squared x is tan x, so it will be tan 3x in this case, but then I have to remember to divide by 3 plus the constant. And now it's just to simplify. If you take your calculator and you say, well, what is 4 divided by 5/3? I'll use my calculator to determine that, and I'll end up having 12/5. X to the power 5/3 plus the 3 will cancel with the 3 at the bottom, and then I will have tan 3x plus the constant. Do you remember in previous examples we said we are going to always give our answers with positive exponents and insert form, because in question papers they ask that from me. Usually they ask me to go as far as insert form if possible. And the moment I see a fraction in this a fraction as the exponent of the x, it's then when I know I can actually write it in insert form. So I can rewrite this insert form. It will be x to the power, the 5 will go inside and the 3 outside, so it's the cube root of x to the power 5 divided by the 5 plus tan 3x plus the constant. If we move to a next example, this example number 7, I have to integrate, but remember, I only know how to integrate if I've got loose terms. And in this case, I don't have loose terms. But if I divide each of these top terms by x squared, I will actually be able to get them 3 loose terms. So in this case, before I can actually start integrating, I have to change it in the correct format. The x to the power 5 must be divided by x squared. The negative 3x must be divided by x squared, and the plus 1 must also be divided by x squared dx. So let's simplify this. This x to the power 2 cancels with 2 of those, so x to the power 3 is left. Or you can use your exponent laws to say, I will have x to the power 5 minus 2, which is x to the power 3. So I'm going to end up having x to the power 3 minus. Now, if you use your exponent laws in this second term, you will say exponent 1 minus 2, so I'll have 3x to the power negative 1. But remember, that 3x to the power negative 1 is that one that wanted me to get screaming previously, so I will rather say, no, want to leave that x below the line in the denominator. This x cancels with one of those x's, so there's an x left at the bottom. In other words, I've got 3 over x. Or even if you said it's 3x to the power negative 1, just to rewrite it as 3 over x so that you can remember the correct rule to use. Plus, and here I'm going to use that rule where I want to integrate an x to the power n. So I have to take that exponent 2 into the numerator position. Now I'm ready to integrate. So I write down what I have, plus 1. So if I add a 1, it's 4, divided by this new exponent 4. For this one, 3 over x, remember, I have that rule that says if you've got integral of k over x will be k ln x plus a constant. So it's going to be 3 ln x. And for the last one, x to the power negative 2 plus 1 is negative 1 over negative 1 plus the constant. So x to the power 4 over 4 minus 3 ln x minus, and now I don't want a negative exponent in my final answer, so I'm going to change the position. I'm going to take that x with its exponent into the denominator position. So it's going to become x to the power 1 plus the constant. Okay, now you'll see I gave you, if you look at it nicely, you'll see what I'm giving you here is actually differentiation rules. But we are actually busy looking at integration. So why am I giving you differentiation rules? This rule, if I use it, reading from left to right, it says like if y is equal to cot x, then the derivative will be negative cosec squared x. So it's a differentiation rule, but remember, I know if I use a differentiation rule backwards, then I actually have an integration rule. So if I use these rules, if I use this rule in the opposite direction, if I use it like backwards, then it will actually be a rule for integration. So it might be that I get a question like, what is the integral of negative cosec squared x dx? But if I check through the list of integration rules, I don't see a rule to be used, no integration rule to be used. But if I check on my differentiation rules, I can actually see, but here I said that if I differentiate cot x, the answer of differentiation will be negative cosec squared x. In other words, if I use it backwards, if the answer of differentiation is negative cosec squared x, I started off with a cos x. In other words, the integral of negative cosec squared x will be cot x plus a constant. So in the next question, question number 9 here, they said, but what's the integral of cos x squared? It's not negative cos x squared. You see, here in the set of differentiation rules, I actually ended up with negative. So what I'll do is I'll say, I already know that the integral of negative cos x squared x is cot x plus the constant. So I may actually take out that negative, and I will have negative times cos x squared x dx integrated will give me cot x plus a constant. It's what we have just said in the previous question. Now, if I do not want that negative there, I'll have to divide with a negative both sides, which means both terms here must be divided by a negative. And a negative will give me the positive, which is actually what I have here. So cos x squared x integrated will be, and that is what I see here, negative cot x. Now, you can say plus a constant, minus a constant. It doesn't really matter because the constant can be any value. Let's look at the next one. They might ask me, so what is the integral of sec 4x tan 4x dx? So, again, if you search through your list of integration rules, you won't find a rule. But if I look through the differentiation rules, I see here, cosec x, cot x, no, it's not this one, sec x, tan x. If I use this rule, differentiation rule, backwards, I will actually have a rule that will help me to integrate. So I'm going to use this rule backwards. If I use it backwards, I see the integral of sec x tan x will be sec x, but in this case, I started off with angles 4x, so it's going to be sec 4x. And remember to divide by 4 plus the constant. Let's look at a next one. In this one, I have 3 terms to integrate. If I integrate each one of them, the first one, I have a constant 2. How can I integrate cos pi x? What is the integral of cos? Now you will have to check on your formula sheet. The integral of cos is sine x. So in other words, the integral of cos is sine. I started off with an angle pi x, so the answer of integration will also have a pi x, but I have to remember to divide by pi. Minus, in the next one, I've got e to the power kx. I'm going to use that rule, which says it will be again e to the power kx divided by the k, which is the negative 2 in this case. And then, be careful, it's not this x to the power n rule to be used. This one is actually, what I have here is the same as 5 over x. So I'm going to actually use this rule. This rule here that says the integral of k over x is k ln x. So it's going to be 5 ln x, and I have to remember to put a constant. If I wrap this up and I simplify each of these terms, I'm going to have 2 sine pi x divide by pi. Negative and negative is positive. I've got a 2 below the line. I don't want to leave my answer with a negative exponent, and I have a negative 2x as an exponent. So I'll take it to the denominator position so that I can change the exponent to positive 2x. Plus the 5 ln x plus the constant is all the terms that I have. So up till now we have been doing integration, but we only looked at indefinite integrals, which means the integration, I got an answer in terms of x in general. Now we are also going to look a quick look at definite integrals. It's where this integral, which I will normally integrate, is restricted between boundaries. It's restricted between a lower limit and an upper limit, which is between a lower x value and a highest x value. So let's say just for a moment that the answer of this integration was capital letter F of x. And let's say that it was 2x. Because I want to show you, why do they say if the answer of integration is f of x between boundaries x value 2 and 3, lower limit 2 up till 3, why do they say f of 3 minus f of 2? Okay, let's look at this sketch. So if I want to know what will this f of x be for x values, what will this f of x value be for x values between 2 and 3? Then I have to see, but with this highest x value 3, the y value that I read off there is f of 3, which is 2 times 3, which is 6. For the x value 2, the y value that goes with it will be f of 2, which is 2 times 2, which is 4. So what will f of x be for x values between 2 and 3? It will be that distance there. It will be the 6 minus the 4. The 6 minus the 4, which is 2. So I had to subtract. So further, you'll see that they say that if the integral of f of x is f, let's say capital letter F, x plus c, because remember the answer of integration always have this constant, and it's restricted between boundaries a and b. I want to show you that if I replace, as we have seen in just what we have discussed, if we replace the x with the b first, minus the f of the a, then I'll have f of b plus a constant minus, in another bracket, f of a plus a constant. But if I remove the brackets by multiplying this negative in, then I will have a plus c minus c, which is nothing. So do you see the c values actually disappears? So from now onwards, whenever I'm working with a definite integral, I'm not even going to mention the c, because the moment I replace the upper limit x value and the lower limit x value into it, the c value is going to fall away in any case. So I will say this answer of differentiation will just be f of the higher limit x value minus f of the lower limit x value. We will be doing one or maybe two little examples. If we look at this example of a definite integral, I will integrate as I normally do. So in this case, if I integrate, it will be 4. I see there's actually an x to the power 0 next to it, so it will be x to the power 0 plus 1, divide by 1. I'm not even going to write the constant, and I know it's restricted between x values 1 and 2, which means I have to replace every x value with the highest bound x value first, and then every x value with the lower limit x value. So it's going to be 4 times 2 minus 4 times negative 1, which is going to be 8, minus a negative 4, negative and a negative is positive 4, which is going to give me 12. So they said I have to evaluate this, and I gave them a numeric value. We are going to stop here. This is the end of the use of integration rules, and then also a little bit of just the start of definite integrals. But you are welcome to use, as you will see on the screen, the information to find us on social media so that you are able to ask your questions. Thank you.